Okay, so NumPy also introduces some more specific data types. This tends to be really important for data science, and for example, certain functions that input NumPy arrays may require the data to be of a certain type. So there's generally needs to do things like convert between data types and whatnot. Okay, so can be a little complicated because there actually are a lot of data types. If you go into the NumPy documentation, there's a whole page just on data types. So you can see there's a Boolean type, there's characters, so signed and unsigned, shorts and longs, all this stuff. So anyway, well, I don't want to get into this in like great detail. I think the main thing that we need to worry about is a couple of the common ones. So Booleans basically allow you to store true, false, logical true, false in a NumPy array. That's basically the idea. If you want to store numbers that don't have decimals, you can use either int or long int, and basically a long integer just allow you to store a larger number of unique integers. And then if you're going to work with values with decimals, then generally we work with the float or double type. Basically, double allows you to have more decimal places than float. And you can also have half precision, which is less decimal places than float. So basically half, float, and double. And then you can get into more complex stuff, which we're not really going to use. So the key thing is that you need to have the data type that matches the type of data that you want to work with. You need to make sure that you can hold all the values that you need to hold. And, if there's decimals, you obviously can't use like an integer type to hold those. So what NumPy generally does is if you don't define a type, it'll just use some default based on the structure of the data. So before we move on to this, let's just play around with an experiment here. So I'm going to add in below here. I'm just going to steal one of these real quick. Actually, let's do that. Alright, so I'm using NP1s to create 3 ones in one dimension, so a vector of 3 ones effectively. And it's being defined as type int 18. But what I'm going to do for now is not define a type and just see what it does. So let's hit that. And we get back float 64, which is, I believe that basically means double float. So even though we didn't, anyway, it's just ones. It basically went ahead and defined it such that it could hold decimal values by default. If we didn't want it to behave that way, then we can actually define the type. So here I'm defining it as int 8, int 16. So this is just an integer. This is also integer, but allows you to hold a larger number of unique integer values, larger numbers and whatnot. And then float 16, which allows us to hold decimal points, and then Boolean type. So let's run this. Okay, cool. So again, we basically have 111 as int. Note that there's no dot, so that indicates that it's an integer. Same thing with int 16, so no dot. Float 16, now we have the dot, which indicates it's a decimal value. It can store decimal values. And then this is kind of interesting. So for the Boolean type, it returned true, 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 which means 111, which because we use NP1s, returns true, 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 or 1 is being treated as true. Just out of curiosity, let's change this to zeros instead and see what it does. So that was false, false, false. And let's just try one other thing. So I'm going to do NP array, or NP array, and then instead of, I'm just going to feed it, let's do 2, 2, 2 this time, and see what we get back. So that also comes back as true. So basically, if you're dealing with Booleans, basically 1 or any other number is going to get turned into or converted to true, and then zeros convert to false, right? So if you feel nervous because of all these different data types, you don't need to worry too much. Generally, when here we're dealing with integer, we're just differentiating integers versus decimal values or maybe Booleans. In the online version of this, let me see here, I've provided some just examples of the numbers here. So again, Boolean, true, false. Int 18 type, it basically can store values from negative 128 to 127. So basically 2 to the 8th unique values or 256 unique values. 16, this takes you up to like over 65,000 unique values. Again, the trade-off here is that an int 16 is going to take up more memory space than an int 18, which means that it's just not as memory efficient. So if you only need to store 100 different values, you could use an 8-bit. But if you need to store 1,000 different values, then you'd have to move on to like a 16-bit. And then a 32-bit integer just allows you to store even more values. 64-bit even more, but again, they just take up more space. Okay, so these are all type int 8, int 16, int 32. So these are all signed, which means that they store negative and positive. Unsigned int basically means that it doesn't differentiate sign or negative and positive. So you get basically the same number of unique values, but they're all positive. So 8 is 0 to 255, or 256 unique values, 2 to the 8th, 2 to the 16th, 2 to the 32nd, and 2 to the 64th, right? And then at our float, we have half precision float, which is float 16, single precision float, which is float 32, and double precision float, which is float 64. And again, this really relates to how many decimal values you can store. So a half precision float is going to take up less space in memory than a single precision float, which will take up less space than a double precision float. I think those are the key things that you need to know. And these are the terms that you can use when you want to actually define them. So when you do the data type argument here, you can use those terms to set it up. Okay, so again, we could talk a lot more about data types and whatnot, how much memory they take up and how you figure that out, but that's not super necessary. I think what we covered here is what you need to know.